actually here, after you switch to the first order, to the second order equation over there, you get the final result. Second order. So the second order, you can see minus 1 here and here. Or might be minus here, point here, right? Already done. Second order derivative. So again, you can compute second order derivative of the function by using convolution to conclusion. The question when using conclusion is what is the value of W for that? So here, that is the conclusion what the kernel are there. All the kernel are there for what? Okay? You have a lot, right? As you can see. So now here, the second order, in Vietnamese we call đầu hàm bậc hai, right? You can approach it by, you can compute by conclusion with the kernel given here, okay? And here I show you about the property of second order and first order. You can see what I mean. Here the intensity is like the value here. First order, and this, second order, and this. Okay. And then the second order you can see here, then minus 1 here. Here 1, right? And here per this, minus 5, and here minus 5. 5 minus 5, right? You can see. So, what is the S related to second order? The portion of the S related to second order. What I mean? For the first order, you can see what I mean. What is the image here? For the here is high value, here low value, right? If you have a picture like that, here is high value, here low value, and here value. For the if I give just one scan line, then the one scan line here high, the low, and high, right? You can see. Okay. But that is the what I mean the rank here. Usually from here, the S usually for real picture. For real picture is different to the artificial picture. For example, if you for artificial picture, you just here is the black, here is white, and here is black, and here is white again, right? But for video camera capture, usually the S is not sharp like this. The S always usually that is the S model, right? So that's why you can, for your eye, you can detect, recognize the fake image because you can zoom, you can see here is fake, here real look like it has fake. Right. So, what I mean the first order and the second order? You can see for first order, minus 1 on this zone. Right? On it means that the first order trying to return the F that is a lot of visual here. Right? If very thick, many visual. That is the property of if you use so well, if you can detect that you see so well. On previous, you can see when you zoom in, you can see the S is very wide. Okay, thickness like this. Yeah, 1, 2, 3, 4. Correct molecule. Right. But for second order, okay, second order, what I mean here? Here you can see minus 1. Here minus 1 here. With it here, 5 and minus 5. So where is it?
The edge of the edge.
Where is it? Right now. Error now E. So you can see this point corresponding to this point. This point corresponding to this point. This point corresponding to this. This point corresponding to this. So where is it?
Start at the end of the edge.
The edge corresponds to 0 crossing. Means that pointed to the edge. So in order to detect the S using second order, you have to go back here. You can detect the 0 crossing. For 0 crossing here, around here, middle. 0% here, you can see around here, also middle. It's very thin, one pixel. Okay. So again, in order to, if for again summarize, if you have image, you want which pixel had a very long intensity, right? A very long variation, right? You should use second first order. First order. But if you want the edge is very thin, okay, then you should use second order. Okay? And second order you have to detect 0 crossing. That's all. This control right body theory. You also have some operator called Laplacian operator, defined by the square symbol square of its component, fs or fy. If derivative on x, derivative on y. And then how to compute it? You can substitute and you can get here, that will be equation. In order to implement the equation, you get this kernel. Yeah, this kernel. So you can have the kernel here in my function code here. Laplacian. You can implement by using conclusion. You can use conclusion. And all maybe here. Again. But the question is, what is application of Laplacian? You have kernel surveyor with robot for F detecting, right? For first order derivative. Okay. For second order, you also have kernel over there. Right? Second order. And what here for the Laplacian? Laplacian will tell you about what? Can you get it? When you apply that kernel on the image, you get the value. What I mean? If all the value on the image in that local picture are the same, so what is the output?
0.
If for image and then here this point and all you can see all the same, you apply kernel there at that point, what is the result for this? 0. So what is the output of this? To detect isolated pixel. Okay? Or we call it the spot point. Okay? Very high or very low intensity spot point. So that is the idea of Laplacian. So you have 4 kinds. Laplacian, this, or this. Here is just different to revert sign only, right? Okay. Here or that. And now what I mean here, suffering image. Suffering image, what I mean? What I mean? To make the image very clear at the boundary or at the edge, because suffering, you can apply this operator. You can compute here by input image, subtract from Laplacian, Float for location depend on the size of the location, right? Location you can see is two ways. The center is positive or center is negative. So you can see, in order to create a softened image, you can add with location. Because location tell you about the difference between the pixel which surrounding pixel. Okay? So that's why you can add. So we have the softened image. And but if not, if like that, but you just apply the color over there and you can image. Here color. For conversion with color on that right, you can create the softened image. Yeah. Soften it. Soften. Can you see? Here the input of the moon, and then here after filtering with location you can add, and here is soften. If you want to create the separate image, you can add this into them. I did. Or you can undo the something by this equation. So therefore, what I mean, the image filtered by the average filter, right? Average filter. What is the average filter? 3 by 3. On the following side, 3 by 3 equal to 1 over 9, right? Yeah. You also have some other kind of the image, full image, we call the high-root filtering. It might be become softened, or maybe you emphasize what kind of the visual inside. So you can see you have very much there. Here the filter. Here is some example. You have Gaussian blur, Ipcv, maybe more blur. Okay, but in soften you have it over there. Have wood with that. So I'll tell you about how to compute derivative. Okay. So again, in mathematics you have first order, second order. You also now first order, second order. Because you can see image at the function f at 1. So you take first order. But the question is how to take first order on of the derivative without or without first order and second order can be computed by what? By convolution. You just select the right way. Yeah. Usually that we put together okay. Just suitable way on. And that is just method how to implement. That is theory. Next, you also because you also have project tree framework to perform convolution to define function to do right over here. Wait. And if you do, and then your project you can see the application of the filter. For example, what is the surveil or privilege or location, what does it mean, right? That's the meaning of the filter. If you apply to image, you get what information? Okay, that is your knowledge. And you have to plug it and you can see. Okay, no.
Teacher, where can I find?
What?
Where can I find this file?
File here.
Yeah.
I just edit, but I had to remove the code, right?
Yeah.
You can see.
Like we need the questions to practice.
Yeah, you have. If schedule, then maybe you lazy. So that's why I had to remove. And they upload programming exercise, right? But actually, I told you before, I do a lot of questions in program for another course, right? Another course. I take a lot of time to edit the question and to put for your exercise. But when up the score and I see the duplication, you copy. Okay, I don't want that. For example, I just submit the score, okay, maybe so student also. For example, another course I call the challenge. For example, here you can see at the time you have log, for example, pi log, and for each of them you also have. For each of them, you may also have a lot of questions inside. Right? So, in order to edit, you also have a solution only, right? It takes a lot of time. But when I broadcast to you, and then just some person do, and then you just copy. Or actually, in Google Cloud, I can detect that. So that's why, okay, a little bit, okay, it's coded. So you can see a lot of, okay, not in this class, you can see because when I see like that, I have stopped, and then I ask my student, okay, in my lab, to verify, to compare what we want. If you have 2 students, you can see. And student, you take number of like that. Okay, pair, headed. So I upload. When I upload, okay, you have to do by yourself. Okay, because I failed. So any question more before we go to the next topic? Any question? Hello? Fine.
Về progress kernel, you say that the kernel have the outside
No.
center.
Usually for different things, okay, the kernel is the host number, side number, for example, 1 by 1, 3 by 4. But some, for example, robots, okay, just 2 by 2.
So how to calculate f1 by
Okay, very easy. Because, for example, here, kernel robot is 2 by 2, right? Because robot is detect not horizontal, not vertical, but diagonal. The difference between diagonal and vertical. So you apply the same as okay, for example here, you apply 2 by 2 here. Okay? So the output, divisor, you get the equation. The difference between divisor and divisor, okay, or divisor, and you have your set for division. That's all. Not different too much.
for the survey, if I want to calculate f1, I just need to calculate at this point because I have the center
I know what you mean. Because that is the even sign, so that's why you don't have, you can compute, you have the result. Okay? But actually, this is correspond to not the center, but the block of this cell with the corner of the block. Here, right? Upper and left, right? This use the block from here to be. For the odd number, you have the center. So why it corresponds to the direct center. Any question more?
About these kind of exercises, we do have to by ourselves. These kind of exercises
That's fine. That might be homework because I don't have time here to solve, right? This is one okay, but maybe I have some look like review, okay? And then I do for you. But not now. You can see it took 2 hours. You can read at home. Or maybe I added to be careful some question to that, and then you can. Again, in BKL, if I have questions, I get the result from my program. Right? Okay, so that's why if there are some error, okay, to inform me. Any question more?
And we can't still can't find the convolution slides on here.
Okay, right now, okay. Sorry. You have a folder I will share with you.
Yes.
I'll be here. I share because maybe upload to detail is maybe slower. Okay, the slide edited for conclusion I upload into the folder I share. And we will upload to detail later. Any question more? You have at least maybe 2 times. Two batch of questions. The first batch is near to the midterm. Even you don't have what that's right, and the second near to the final. If you had a midterm, right, near to the midterm maybe before 1 or 2 weeks ago, near final also I've got one back. For 5? Oh, okay, I will try. I will try. Look, maybe very quickly, right? You want to. Okay. Any question more? I only remove one chapter because due to the copy only shorten on number of hours. So again here, Maybe I upload the line that you can read it for, right? We have linear and also non-linear. So the question again, why we call linear completely linear? Because the output value is equal to the linear function with the with the value of input, right? Okay. By inclusion what we kind of with the output equal to WTF plus B. Right? For each pixel it has the following way without here, B with here, F without the following sub local. You factor. So on the linear filter, we are able to eliminate by using convolution. Okay? So convolution means not linear. Okay? Linear not convolution. But there are other operations you have non-linear. Non-linear, for example, you have for example, median. Very well known as median filter. Other kind of static also, right? Other kind of static. Okay. So for example, if you have the one of filter look like for the way we give you the limit like that. This or this or this. Can you recover the image original clearly? Right? That is the application of very well known medium. Can you see it? And can you see what is the noise? In which application you have this noise? A lot, right? But in the part that is the image you get from the satellite outside, usually because there are some dot here less and why maybe it's paper without glass, so we don't know why. So how do you also have kernel, but kernel there are no value. No value. For example, 3 by 3. You pick up 3 by 3 minute 9 value here. You take median, you put up the output median. Then median what I mean even mean? Trung vị, how to compute the median? Short it, take video. And that's all. So you have it. And median filter is also very well. Not only on space, not the here image we on space, but also on time. For example, video. For example, if you take a video from the camera on a short right, fixed camera, can you see a lot, right? Fixed camera. Can you remove the object? You take only the background. We call the background modeling. Application we call again application of median here is to remove paper and soft noise, right? First base. But for time, for example, if you had a video, you have concept of background model. What application of background model? Yeah, you take the camera over the can for there are some cars, some motorbike go up, go down, right? You just get the background how to. Not how, but what application? A lot, right? A lot. Maybe detection, maybe you create the image also. But here you apply background and how you apply median filter on the time. On the time without you have, because median very simple, you just get the log value, you short it and you get the value middle, right? And you get the background. So you have a lot of like that. Let's see my slide. Now go to the figure Fourier transform. In that in frequency domain, we project it on frequency domain.
Teacher, so sorry, can you spell the name of the data and background model?
Background modeling.
Modeling. Oh, okay.
Now we go to Fourier transform. Let's talk about the Fourier transform. I think it belongs to the 10 important algorithm in the decay. Let's see, show you about what implementation of that. Okay, nanti. You can see the why we study about the Fourier transform. The Fourier transform is very important for the electronics and electricity. You can see all of the technology right now is used almost used fabric. Even the for example, you can see, for example, at least you feel the signal from the point here around also. So the question is, now we study image. So what you do, man? Because you can see further. Furthermore, you can perform convolution. But the convolution is how to you apply the kernel. Apply here, you take multiply, okay? You compute by this formula. And this formula applied for each of this one inside. So it takes a long time. Eventually for the y kernel be bigger. Okay? So that's why how to accelerate complete pattern using, for example, I remember CUDA of NVIDIA GPU card. Let me try again. CUDA. Okay. You can see, even for deep learning right now, the commonly compute by everything, because it is very fast. It's fast. So okay, that is application a lot in our field. I show you for example some. Yes. For example, even you can see, if I want to detect S, only S, or I want to make the image become blur. Or even we remove the bottom line from image this, you recover image line. Then you also apply in frequency domain. It's better, fast. Okay? So the question is now what is the idea first? What is the idea of the Fourier transform? The Fourier transform, right? You can see what idea. You have an image. Look at the wall. If it takes the one skyline on vertical or horizontal or vertical, you have the sequence of value, right? Right? That is we call signal. That we call signal. Then you can see what is the idea of the Fourier transform. Based on the theory of Fourier, all the signal is composed of many frequencies. Okay, without the fungible lines, you can see the line. You can optical prism. You take the different color, you can see different color because each color corresponds to the one frequency. And now you have a tool of DFT, we call Fourier transform, decrease Fourier transform, also do the same. You find a signal, and that sequence value, you get frequency. You detect which kind of frequency inside or which frequency inside of the signal. So that is the idea. And if you have a network application, you can remove some, you perform filter or remove some frequency. That's the idea. Okay, now you can see. So what is the idea? The question right now. In this you have FU. Remember that is my notation. You have S small in space domain or in time domain. Now in time with 1D first, right? 1D first. Because for internet 2D, from one row by row, column by column, right? So you have 1D first. So F in time domain. And here, uppercase in frequency domain. Okay. And this equation here is related to the complex number. Okay, I review a lot about number. Do you know the complex number A plus JB? You know that? That is the point on plane, right? That is the real. That is the image. The Z here is the point on plane. So Z equal to R mean for example here. That is Z. Here is A. Here is B. So you can write A plus JB or I. That is the representation of complex number. Or that is the distance from origin into the number at the point you get R. And got the angle here we call alpha. So also another representation here is Z equal to R multiplied with J of alpha. You have Euler angle, Euler formula. We have J alpha equal to cosine of alpha plus sine. And there are some review, some basic. So now let's here. So that formula, you can see n is the number actually from 0 to n minus 1, right? Because n here from n minus 1 that is my bit. So that formula equal to F0 equal to F0 multiplied with E of J 2 divided by M multiplied 0 with 0. Right? Plus F1 multiple 1 plus plus with f of n minus 1 can see it. That is formula. That is the formula. And you can see what are the U from also from 0, 1 to n minus 1. U also you switch to 0 for 0, 1, 0, 0, 0. So F1 equal to 1, 1, 1, 1. So now you compute easy. You compute easy. But actually, what does it mean? That is important. What it mean? Why we call frequency decomposition? In German, the frequency decomposition means that phân rã ra tần số. What does it mean? What? So you can see what I mean, right? So I give you about the idea of different. Can you see here figure? Here the figure. I draw 1, 2, 3, 5 signal, 5 sine function, right? With different frequency, different magnitude on left side. Can you see? Only sine function with different what? Different frequency, different magnitude only. So you can see that, right? So remember frequency is different. So now if I add on a phi function here, S to